Good evening. Today we're going to discuss the properties of magma by me, Christina Flores. Before we talk about that, we need to first talk about physical and chemical properties. Why is it important to know the physical and chemical properties of a substance? Each substance has its own set of physical and chemical properties. These properties can be used to identify a substance or to predict how it will behave. Physical properties are characteristics of a substance that can be observed or measured without changing the composition of the substance. Some examples are density, hardness, boiling point, melting point, and whether a substance is magnetic. Chemical properties is any property that produces a change in the composition of matter. Some examples are substance ability to burn, the substance ability to combine with other substances, the substance ability to react with other substances. These examples are things such as color change, they produce gas, forms new gas, or forms a solid substance. What is magma? Magma is a hot fluid or semi-fluid material below or within the Earth's crust from which lava and other igneous rocks are formed on cooling. Some examples of the rocks are rhyolite, andesite, and basalt, as you can see the pictures below. Alright, magma. Magma is formed from the melting of metamorphic rocks inside the Earth's crust or mantle. All magma has varying types of chemical properties depending on the rock it was formed from. Two actions of magma. Magma can cool slowly within the crust over centuries or millions of years to form intrusive igneous rocks. Magma can also erupt onto the surface as lava and cool quickly within seconds to years and form extrusive igneous rocks. The properties of magma we're going to discuss: temperature, silica content, and viscosity. The temperature. The temperature difference of magma produces two different types of lava. Pohohi, I think that's how it's pronounced, is fast-moving hot lava. It looks like a solid mass of wrinkles, billows, and rope-like coils. Is cooler and slower moving lava. It forms a rough surface of jagged chunks. Next is silica content. The major ingredient in magma besides oxygen is silica content. It's about 50 to 70% silica. Oxygen is the major ingredient. The more silica magma contains, the higher the viscosity. The less silica magma contains, the lower the viscosity. High silica magma produces light-colored lava. Example of this is rhyolite. Low silica magma produces dark-colored lava. Example is basalt. Next is viscosity. Viscosity is the resistance of liquid to flowing. The amount of silica magma helps to determine its viscosity. The more silica that magma contains, the higher its viscosity. The less silica that magma contains, the lower its viscosity. Low silica content creates easy magma flow. High silica content creates slow magma flow. As the temperature decreases, the viscosity increases. And as the temperature increases, the viscosity decreases. Here's what we've learned. High viscosity equals low temp equals high silica equals slow flow magma. Low viscosity equals high temp equals low silica equals easy flow lava or magma. Here are the sources I used in this PowerPoint. I hope you enjoyed it. Thank you.